Welcome once again to our last session of 8-2-C-5-5 discussion. In this section, we would like to have the detailed discussion on the control pin configuration by using port C for handshaking I/O operation. Okay, in this figure you can see for in operation for port A, port C, 3 pins of port C, 3, 5, 4 and 5 are used for handshaking, where 3 is using interrupt, 4 is using for strobe, 5 is using for IBF, input buffer full. Okay, and for group B or port B, PC 0, 1 and 2 is using for handshaking. Okay, the same, one is input buffer full, strobe and interrupt. Okay, but for output operation, for port B or for group B, the pins are same, 0, 1, 2. The name is a bit different. One is OBE, that means output buffer, OBF, that means output buffer full. Another one is acknowledgement, ACK, and the same interrupt. Okay, but for group A, interrupt pin is the same, PC3 is the same, but for out operation, PC6 and PC7 is used. Okay, that means since port A will be used for I/O, bidirectional I/O, so 5 pin is required for this. 3 pin is for in and other 3 pin is for out. And here the interrupt pin is the common for in and out both operation. Okay, so take a look here. You can see here MPU is going to send the data to the printer by using 8-2-C-5-5. So MPU will send data to 8-2-C-5-5 by enabling write pin, write control connection. Okay, so number 1 at time 1, if we say timing, so at time 1, write control connections will be activated and data will go from MPU to start going from MPU to 8-2-C-5-5. Whenever 8-2-C-5-5 got the write pin activated, at that same moment, or you can say on time 2, it will generate an interrupt to the MPU. Like now I am working your task, don't send me any more data. Okay, now I am performing your job. I am busy with your job, your work. Okay, okay. Then after receiving the data, when the data will come to the data bus buffer of 8-2-C-5-5, the data and write connection completed their task, it will be deactivated on time 3. Okay, so now 8-2-C-5-5 got the data. Now it need to send this data to printer. Now it will lock the printer. Okay, it will knock the printer on timing 4 by using output buffer full control connection. Okay, that means PC7. So PC7 will send 0 data, 0 to printer. When printer will receive this data, if printer is free, it will acknowledge at the same time on timing 5. Okay, or if it's busy with some other task, maybe after some time, after finishing that previous job, it will send an acknowledgement on time 5. When 8-2-C-5-5 got that acknowledgement, it will start sending data from port A buffer to printer buffer. Okay, on timing 6. And at the same time, when it get the acknowledgement, OBF, the task need to done by OBF is finished, so it will be deactivated. Okay, it's done. So on 6, OBF will become neutral, and on port A, data will go to printer. So when data will arrive in printer, or after receiving the whole data in printer, printer will generate an acknowledgement signal to 82655 or to PC6. So when it sends the acknowledgement, okay, that means the data is arrived in printer on timing 7. So after getting that confirmation, 8255 then deactivate the interrupt signal control connection. Okay, that means now I'm ready for another input, or now you can send me another data. Okay, so that is the time configuration. You can find this time configuration here. First, write, then interrupt generation, second interrupt generation, 3, write is deactivate, 4, it will generate the OBF signal to the printer, then it will receive acknowledgement on timing 5, then it will send data to the printer, and also OBF will become deactivated, and when the printer receives the data on timing 7, yeah, printer confirm that I received the data, then interrupt will be deactivated. Okay, this is how the things work. Okay, in the same way, for input operation, opposite thing happen. Input will come from keyboard. Okay, it will generate a stop signal, number 1, stop signal, and send data from keyboard to the buffer, number 1. Then 82655 or PC1, by using PC1, it will send a acknowledgement to keyboard like, now I am doing your task, don't send me anything else. I'll let you know when I'm finished. Okay, so by using IBF, input buffer full, it will send a signal to keyboard, don't send me anything. Okay, on timing 2. So on timing 3, it gets the data inside the data buffer. Okay, so at this moment, at this timing, it will generate a request to the microprocessor by using interrupt control connection, like, now I would like to send some data to you, Mr. Processor. Okay, processor will see, if processor is free, then of course it will generate the read control signal. But if it's busy, it will send the read control signal after a while. Okay, so on timing 4, interrupt is generating for sending the data from 82655 to the microprocessor. Microprocessor will respond on timing 5 that I am receiving the data. Okay, so on point 6, interrupt is done, complete, like it was calling, so it got the response, I am done. Okay, so on timing 7, data will come from 82655 to microprocessor unit. Okay, so when the whole data will come to the microprocessing unit, then the interrupt will get deactivated. Okay, that means, the IBF for keyboard will deactivate it. That means now I can receive another information from you, or another key information, or another data from the keyboard. Okay, another scan code from the keyboard. Okay, so that is how the input operation perform. Okay, you can see here, first stop control signal from keyboard to the 82655, then input buffer full signal to the keyboard, then after receiving the data, it will generate interrupt request to the microprocessor. Microprocessor will generate read command after receiving it, After sending this command, interrupt will be deactivated, and after receiving the data, the IBF signal will get deactivated. Okay, so this is the time diagram for reading the data from keyboard to microprocessor. Okay, so the same thing happened for bidirectional I/O also. Okay, for the bidirectional I/O, you can see on port A, PC3, PC4, PC5, PC6, PC7 is using for reading and writing operation. Here you can see the same time I/O is not going to work. Bidirectional doesn't mean at the same time it's sending data and receiving something. No. Okay, you can see in this timing, first the MPU is receiving from, okay, so first MPU is sending some data from microprocessor to the touch screen, and on this timing microprocessor is receiving data from the touch screen by using PC3, 4 and 5. But for sending it was using 3, 6 and 7. Okay. So I will give you the time diagram on your slide for read and write handshaking bidirectional I operation. Okay. So it was about 802C55 interfacing IC. Okay, now you know how it works in mode 0, mode 1 and mode 2, and now you know how the handshaking happened with port A and the microprocessor, and also port B and the microprocessor for handshaking in or out, or even for port A bidirectional I/O. Bidirectional doesn't mean it's going and it's sending and receiving at the same time. No, in one timing it's sending, in one timing it's receiving. But this port can be used for bidirectional device. Like this is not only touch screen but also all the secondary storage or storage medium. All these are used by using port A. Okay, like for writing and reading, writing to the hard disk or reading from the hard disk, or writing to the tape drive, or reading from the tape drive, or writing to the CD-ROM, or reading from the CD-ROM, it used port A. Okay, since it's a bidirectional I/O, since it supports bidirectional I/O. Okay, once again, not in the same time. System bus, 8-bit system bus cannot send and receive at the same time. In one timing it's sending, and in one timing it's receiving from the same device by using the same port. Okay, that's the fact. Okay, so thank you very much for listening my lecture. Maybe on next time we'll come with some other topic. Thank you.